So as Jeanette told you, I'm a research engineer at Fairfax in Toulouse. So I worked a lot in providing climate data to users. Now I'm working more on the infrastructure and improving the access to climate data for all kinds of users. So I will present you today what is available now to access climate data and tools for end users. So it's really an overview, and I will really try to show you what are the advantage and disadvantage of different data access portals we have. So I begin with the main infrastructure behind all those portals is the ESGF infrastructure. So it is a multinational effort. So it's a worldwide effort to give access to climate simulations that are produced by several countries and several institutes. And it's really the reference to provide data for climate research to get access to those experiments and observations. So the ESGF is Earth System Grid Federation. It's a globally distributed infrastructure that also disseminates climate-related data. It was originally developed to support CMIP 5, so it was related to the fifth couple model intercomparison project. So the climate researchers are producing several climate simulations, and they want to intercompare their simulations because they are using different climate models and different approach to do future climate projections. So the goal here was to share those results and let the researchers compare those results. And to do that, you need to provide access to your simulation. So each institute had to provide their simulations to the other institutes. So this is how this ESGF was originally developed. So for this purpose. It also provides a mean for climate data users to access and analyze those outputs. So not only the climate researchers, but those doing climate impact modeling or climate impact studies. So it also provides this kind of access. It was also heavily used to write the IPCC report. So those reports are made for the stakeholders and the political agenda. And this infrastructure was also used to get access to data to produce those reports. So it has been 10 years of operation, and now it has grown to support over 25,000 registered users. And not only CMIP simulations are provided, it also hosts data from other projects. For example, I list a few examples here, but there are many more. So we have, for example, energy exascale Earth system model output. We have OPS for MIPS, so observation intercomparison too. We have the Cordex. I will be talking a little bit more about it later. And some data from the ESA, so European Space Agency, with climate specific variable. So we have an important experience that we have gathered over the years. And it's a community collaboration, which means that it's really those institutes and those data centers getting together to provide this kind of infrastructure and software to support this infrastructure. So there are operational procedures and governance to be sure that this infrastructure goes on. So now we have CMIP6. So it is the new intercomparison project with new climate projections and simulations. It has been launched in June 2018. And now we have, at that time, we had 218 different experiments to tackle different scientific questions. We had 37 institutions participating, 94 CMIP6 models, and distributed over 30 data nodes over the world. And so for this new set of the climate simulations, about 18 petabytes of data are expected. So many of you maybe were involved in using CMIP5 or CMIP3 data. So we have new greenhouse gas projections that we use to do some experiments. So in CMIP3 we called them SRES. So and in CMIP5 it was called RCP, and now in CMIP6 we have SSP. It stands for Shared Socioeconomic Pathways, and those are different evolution of the greenhouse gas concentration in the atmosphere, given different decisions or that countries will try to follow to limit the amount of greenhouse gas in the atmosphere. So we have different paths that we don't know exactly which one we will follow, depending on how people will follow guidance, how the countries will, what the countries will do to reduce those greenhouse gas. So we have 5 different ones. Five different aspects. And so we have this matrix, and we didn't do experiments for all those different combinations. So we have the tier 1 and tier 2. So the main ones are the tier 1. So most of the simulations that you will see available will be those tier 1 simulations. And we have on the y-axis, we have the correspondence to CMIP5 RCPs. So we have 2.6, 4.5, 6.0, 8.5. So you can see the correspondence with the SSPs we have in CMIP6. So if you want more information, there's publications in GMD that explain this in much more details. So accessing CMIP6 data, so the basic access is through the data nodes of the ESGF. So this is as I said, the main infrastructure, and all the other portals are using in some ways those data nodes in the backend. So, but you can access them directly yourself. It's more complex because you need some guidance, and if you are not an expert, it's difficult to use. But I have put here a screenshot and a URL where you can access it. So this is one data node located in the US, but you have other ones located also in Europe that you can get access to. In those data nodes, you have the global climate model experiments that I have explained a little bit. You can also have access to the Cordex experiments. And those experiments, the ones available are still based on the CMIP5 climate simulations. So there are no Cordex original simulations based on the new CMIP6 simulations. So those Cordex datasets, what are they? If you don't know them really, they are aimed at some regions. So we have different regions where we run higher spatial resolution climate models, and it uses this framework. This framework has been decided in 2012. So we have different climate projections. So we run those over multiple regions. The initial focus was on Africa, but we now have regions all over the world. It's mainly 50 kilometer resolution, but we have higher resolution in some regions. For example, over Europe, we have 10 kilometer regional simulations. And it is run over several RCPs and using different global climate models as a forcing, because for regional climate simulations, you need to have a global climate simulation as a forcing. So several climate models are used and using several RCPs. So in the end, we have projections over 1950 to 2100. And this gives us access to higher resolution regional climate simulations. They are available through the data node themselves, because all those Cordex datasets are stored into the ESGF data nodes, so you can access them to the more search options in the data node page. There also exist several other higher resolution climate simulations. The biggest dataset is Cordex Adjust, and you can see those. You can access those simulations also in the data nodes, ESGF data nodes. So those are regional climate simulations, but with the bias of the model removed. So it's called bias adjusted RCM data. So RCM for a regional climate model. But those are generally considered better. People tell you, okay, it's better to use those adjust simulations because some biases are removed. This is true, but you still need to be very careful in using that kind of data, because you need to know what are the pros and cons, because it's still a controversial approach. It should be used very carefully. You should really understand what kind of limitations and what is the approach used, because there are many different ways of doing bias adjustment. So there are some limitations that you need to be aware that are listed here. So the biases may not be removed completely, depending on the method used and the data used to remove the bias. When using bias adjustment based on average, the extremes may still be over or underestimated. So if you are working on extremes, you need to be careful if the methodology is based on average. When it is used on each climate variable separately, it could introduce some inconsistencies between climate variables or decouple them. So if you are using climate indices that are if your impact model is using several climate variables at once, you may introduce some problems in your climate impact modeling or your analysis. The bias may be different for different regions. For example, the climate model could have a bias over specific terrain, for example, in mountains or different kind of forest, or could have a different bias. Bias could be also dependent on the season. So the adjustment, if they don't take that into account, you will introduce different biases. The reference dataset that is used to remove the bias, if the reference dataset also contains biases, then some bias will still be in the output. So really use high caution when using those kind of bias adjusted data. It's not a problem to use that kind of data set. You just need to include those limitations and understand those limitations when doing your analysis. So now, getting into more advanced portals that are built on top of the EHDF data node. For example, here we have the Climate for Impact. So I present you here the operational current version. We are developing a new version of the Climate for Impact portal that will provide more advanced feature for interacting directly with the data. But the objective remains the same. So it gives you access to all EHDF distributed datasets. So this means CMIP 5, CMIP 6, Cordex, Adjust, and all the different experiments and specific datasets that I have presented before. So the ops for MIPS, the ESA datasets, so everything is available. There is a lot of documentation and guidance that you can explore to help you understand the data and how to use it. So there's scientific documentation on the climate system itself, on climate numerical modeling, on different downscaling techniques, bias adjustments, and some case studies examples. And you can also have access to on-demand processing capabilities. So present here the search interface. So as I said, it's using the EHDF data nodes. So to filter the data sets, we use facets. So those facets could be the parameter, the frequency of the data, the specific climate model, and it is used to, you can explore and also use your own data set if you have hosted them somewhere on the internet. Once you have selected your dataset, you can do on-demand map and plots and processing. So the new version will also be presented next week. There's also the Copernicus CDS, so the Climate Data Store. So you have the URL there. So it's really more toward climate services. The Climate for Impact portal is more oriented toward climate researchers, climate impact modelers, PhD students, postdocs, and this one is more toward the climate services, so more operational-like service to support small companies doing climate impact studies, for example. It has a toolbox, an API to build applications, and some application already available too. It hosts access to CMIP 5, Cordex, EOBS, and the most used datasets are available, but not all the experiments. For example, many datasets available in Climate for Impact are not available here. And also important thing to consider is that the CMIP6 datasets are not yet available. And it's really even CMIP5, you don't have all the experiments. It's only the ones that are most used for climate services. So it's really the mainstream ones. So a selection has been made, and it's not using the ESGF data nodes, it's using a specific one, specific for the CDS. But everything has been validated for the quality of the simulations included, the subset, and support is available too. So here I have an example on CMIP5 data selection. So you select, this is the download data tab and functionality. So you can specify your experiments. So it can be specific RCP, historical, or IMIP. And then you have the variable below that you can select. There are tutorials available also in the user learning service. You can also interact directly using a Python code. You can only use functions that are available in the CDS. You cannot use external functions, but they are really easy to use. For example, here I produced the plot on the right-hand side over France, and with the surface air temperature anomalies relative to the period 81-2010. And the code is very short. Yes.
Can I ask something? What we see here is your screen, right? So not what people will see when they go to the climate data store, but this is what you did on the. They cannot reproduce this because it's yours, right?
I used an example in the gallery. In the gallery, you see on the left-hand side, you have a list of already made applications and small code. And you can use that as a template and then modify the code to suit your need in your account. So this code, I didn't write it. I used it in there were several examples available in the toolbox. So you can start from an existing code in the different code available, and then you can modify it for your.
Okay. Yeah, that's what my question was. Did you change the Python code, but you didn't? You just used what was available. No. Okay, thanks.
But I ran it over France, and but I didn't. I see a question, but I cannot see it. Can you tell me what is the question, Janet?
No, I would like to ask you to go slightly faster through the slides, so we have time left for questions. Yes.
Okay. So there's applications community sharing. So this is what I used, and you can do the same using the API to develop complete applications. There's also MoreClaim. I think many of you maybe have heard about it. It has really fine resolution, observation, and future projections, but it has a very basic scientific downscaling methodology. So be careful in using that. There are no corrections for inhomogeneities, for example. It's mainly interpolation using elevation and distance. So I think it's good if you don't need advanced downscaling methods and you don't need high precision. But you need to consider that when you analyze the data you produce out of it. But be very cautious, I would say. Sometimes people use that because they don't have anything else. So I would say read the documentation and read the pros and cons and how it has been produced. There's also Climate Adapt done by EEA. You won't see any dataset available there but you will see a large documentation and guidance that can help you on how to do your study. You can explore other adaptation studies to see how other people are doing it. And I think it's very good to look at how it is suggested to do it and have some guidance on how to develop the adaptation strategies that you need to do. There are some videos also available. So I think it's a very nice portal, even if you don't have data sets. There is IMIP, so it's Intersectoral Impact Model Intercomparison Project. And I think it's very interesting for you because there you can see intercomparison, but not for climate simulations, but for impact model simulations. And it has a large number of impact modeling datasets. You also have a protocol on how they did the impact modeling. So I think it's very useful to know how to do it for if you are doing impact modeling, how to do it, because since they have a protocol here to intercompare, it means that it's what they suggest to do impact modeling using the different simulations available. Either, for example, they are using Codex, and also there are some impact modeling, I think, for CMIP 6. So it's really a good guidance and a good protocol, I think, to know how to do those kind of impact modeling and analysis. This is their page. So we have information on how to get started. They have information about the impact models they have been using. They have their output data sets available, and some analysis they have done using this output data. There are also some remote services to do remote calculations, because sometimes you need a large number of data sets, so it means large input data, and that you cannot download all those data sets as input and process it locally. It's too heavy, it would take too much time. So there is a service called ENES Climate Analytics Service. So it has been developed within the IS-ENES project. So you can do remote calculations. And there are two endpoints, CMCC and DKRZ. And they provide you significant computing resources. You have free registration, and there are examples, workflows, and Python-based Jupyter notebooks. And there are some training material available. So if you need to analyze large data sets, I encourage you to look for that too, because it could really accelerate what you need to do, because you can use those remote resources funded by the IS-ENES project. So to summarize, well, before summarizing, there are also other portals with data in tools available. So there's the Climate Explorer, there's the European International Climate Assessment Database. Some of these are available through the Copernicus CDS. There's the Climate Data Guide. There are also some other portals with some tools. For example, the Climate Data Tools from Columbia University. There's Impact2C project with some impact data. And there are also national portals. Here I present you the one in France, but it can give you some guidance too, because there's an English version, and you can also get some information, but those are only French datasets. But there are other portals in other countries too, in Europe. So some thoughts to summarize all of these is that there's a large variety of portals available with there's non-homogeneity in available datasets. They have each very different capabilities and interfaces. It may be difficult to know which one is suitable for your specific needs and knowledge. Guidance is usually not always sufficient, I would say. It's very inhomogeneous. Support may not be available for all those portals. Applicability and caution about those datasets and their possible use, it's not always obvious. You need to take care of that, I think. On-demand remote calculation and subsetting is not always possible. Downloading the results in digital format also is not always possible. So sometimes you only have plots in the output. And if you do impact modeling, you need the numerical data. Also be attentive to fairness compliance, which means if you want to reproduce the experiment later on, or know what kind of processing has been done to your data, sometimes it's not always available. For national, regional, and local studies, I think you should look into national portals first, but be careful that you have enough simulations available for the uncertainties aspects. So the Climate Adapt portal is a good resource for guidance. I would suggest you to look into it to start. Some last thought. I think it's good because there has never been so many accessible climate datasets. On-demand remote calculations was not possible before, but now it's rapidly developing. And there is an increasing number of higher spatial and time resolution datasets. This is true for gridded observation and reanalyzed datasets too. And uncertainties can be better estimated because we have a larger number of simulations, and we have also remote calculations. And European-based portals integrating several infrastructures and tools and capabilities are being developed right now and launched. And cloud-based solutions are emerging, which means that you can do more and more remote calculations. So I will end